thank you everyone for joining. I know it's 1 minute past 10 and I think people will slowly come joining in, but this is our first annual tinyML meeting for ANZ, and looking forward to hosting many more. And again, I'll give you a bit of insight into, what the plans are. But today I'm very excited. We have Scott from here from DXC Technology to talk about his project, which is the Race Predict, harnessing compute at the edge to identify objects moving during sport events. But before we get to Scott, we'll talk about a few things, talk about our presentation, our meeting, and some of the other points. Let me go. But obviously, before we continue, the only way this is possible is through our sponsors. So, we've ARM, obviously a great processor for the deep edge, Deep Light, one of the development environments, Edge Pulse, Maxim Integrated, Quexo, Reality AI, and SynSense. If you're looking at being a sponsor of tinyML, please contact Betty. I've been in contact with Betty because I'm looking at having us sponsor tinyML, but definitely open to have more sponsors of this great group, and obviously keen to grow the tinyML topic and subject for this region. There is another presentation, and for those who are willing to jump on, there's a presentation from Mohammed Zabia, from an associate professor from the King Khalid University Centre of AI, on oral tongue lesion detection using tinyML on embedded devices. So another interesting talks, and again, any of the tinyML talks are available online. So feel like, don't feel like you have to join them live, although we appreciate when you join live. You can always look at the recording and then ask notes later, and then we'll try and get the information for you around those particular slides. So Scott has worked in technology, the last 20 years, currently with DXC as the chief technologist, correct?
Yeah, that's close enough, mate. Chief engineer.
Chief engineer, that's all right. And with a big focus on continuous learning, using nascent technologies and developing innovative ways to increase automation and business value for customers. So again, really grateful, Scott, to have you present today. And I will hand the reins to you. So thanks, and please, anyone, if you have questions, I'm monitoring the Q&A. So please send through any questions or any comments that you have, and I'll try and answer them.
Thanks, Nick, for the intro, and thank you for the opportunity to let me chat about Race Predict. I've presented it a couple of times internally within DXC, and everyone has quite likes it. So hopefully the audience will also like it today. Just quickly on the agenda, we'll talk about the business challenges and value. There's no point necessarily talking about the technology unless there's a why. So why are we developing these solutions and solutions at the edge? It's really to deliver business challenges and value, or address the business challenges with the tech. I'll go through a demo of. I've got a couple of videos that we've pre-canned, ready for this session. The technology overview. So there's quite a bit of machine learning and AI that is it's the core and heart of the solution effectively. And then deployment options, cloud deployment options, as well as doing inference at the edge potentially. We'll talk about those and some next steps and Q&A as well. So if you do have a question as I'm going through the slides, feel free to raise that question, and we can address it at that point in time. All right, so the core of the business challenge that we're looking at and trying to address here is there are, in Australia, we've got multiple races where our customer is trying to prioritize the best vision, and all of these races are conflicting, and the goal for the people that are working in this environment is to try and direct the priority racing vision to their priority racing channels. So they're looking at, if you picture yourself in a like a dark studio with racing screens, in front of you. It's kind of like a dark cockpit, and the people that are working in this environment are looking for when the next race is going to start, which is the most, which race is the highest priority that they're trying to get onto their premium racing channel. So it's quite a challenging mental challenge that they've got to work out when is the next race is going to start, how long is it going to take, and so working through that is quite a challenge. There is also business value linked to when the race starts. So there are on-screen triggers, things like market movers or big bets, and that also drives more betting revenue, and it's currently linked to the scheduled race start time. So in terms of looking at the summary of the business value, we want to try and get that priority vision onto the priority channels, as I described before, and that increases the customer satisfaction and ad revenue. We know that automation here will reduce employee effort, and it also make them happier and healthier, and enable them to work on higher value tasks. The on-screen triggers linked to the predicted race start time are of higher value to customers and the business. There's also an on-sell for, if we look at high value punters, they try and time their placement of bet to almost the last second to get the best odds. So there's an opportunity to sell the predicted race start time to those customers as well. So working through trying to solve the business problems that I've described, I feel that there's some additional value that we can also add. So if you look at the picture on the right hand side there, the Ballina race, for example, the zeros at the top there, which is effectively how long until the race start time. So that shows that it's 0. So right now, this snapshot was taken of this screen is the actual race start time, but we can see that there's still a number of horses that need to go into the barrier. So punters, and I'm a punter myself, I gamble responsibly though, it would be of benefit to actually show on this screen when the predicted race start time is. So customers are better informed around how long until the race start. So it gives an opportunity maybe to put a bet on. So that can also drive revenue for our customer as well. High value punters also bet via API and in an automated way. So the scheduled race start time isn't necessarily of great value, but providing the predicted race start time can feed their automation and API betting also. Working through the additional value as well, I trained the model, the object model, to detect when the race has started. So right now, I know our customer currently has a studio set up, and they look for this, watching this vision in the studio, and they'll press the stop sell button, so no more bets. So there's an opportunity here, I think, as well to do that in a quicker and automated way. So stopping the betting by in that automated way like I described. All right. So we can also do it for greyhounds. So here in Australia, we've got dogs that are very fast. They run at about 60 kilometers per hour. So we can do the automated stop sell for greyhounds. So this is very latency sensitive. The first second or two of a greyhound race quite often will determine the winner because the start's incredibly important. So if we're able to detect the race start and do the inference at the edge, for example, that reduces the latency, and then feed that metadata into the object model upstream, that could mitigate any risk around the stop cell, being pushed too late in that process, in the pre-race start transitioning to race start. And it also can give the opportunity for our customer to leave the betting open for longer, which drives more revenue as well. That talks to that business value discussion. You can see here as well, I'm not sure if you can see it very clearly, but we can also highlight specific racing events or racing images. So we've trained this object model to just look for the Greyhound #1. So as we're watching this video, this object will follow the Greyhound around. So the use case for that is, or the value for that is, if you're a punter and you're watching the race on your digital device, quite often you're quite curious and interested as to where your horse or your dog is in the race. So we can identify that animal and put maybe a halo on top, so that as you're watching the race, it's much easier to identify. So that should improve the customer experience as well. All right, so enough of me talking, and just move to the demo. So you can see here we've actually, before I do that, where's that other slide, the demo explanation? I've gone too soon for that. Bear with me for a sec, I'll explain it first.
Yeah,
here we go.
I was going to say as well, Scott, these are, at this point in time, these are fixed cameras, yeah?
Yeah, so at the moment these cameras are fixed, and they're provided by the broadcaster that is at the track. Yep, that's right. Okay, so just talking to the demo and providing a bit of an explanation around what you're going to see. So if we look at the left image here, as I described before, this is a race that's at Ballina, and it's at the scheduled race start time. So that's the 0. Down the bottom here, we have an object model which is detecting how many horses are in the barrier. So the green images that you can see there, you may need to zoom it up a little, zoom in a little bit, but it shows, it's counting the horses in the barrier, and it's also counting and detecting the barrier empty. They're the white images that you see there. So the Grafana dashboard that you can see down the bottom left, the green lines there is effectively counting the number of horses that are in the race, number of horses that are in the barrier, and the blue line just above it is the number of starters in the race, or the number of horses in the race. And on the right-hand side here of this dashboard, we can see that we're predicting the start of this race to actually be in 30 seconds. So if we were to move this into the production environment, what we'd like to be able to see on this shot is the predicted race start time next to the scheduled, or maybe even replacing it, and you would have 30 seconds to the race start. And effectively, these are just tickers, and you'll see that in the demo. So on the right-hand side here as well, is effectively it's the same Grafana dashboard images that we can see here, but it's a little bit further advanced, where the race is actually started, and we're detecting the racing has started, yeah, that's that that orange line that's on that Grafana dashboard there. On the right-hand side here, you can see the scheduled start, how long until the scheduled start. So obviously that's decreasing. So as time goes by, the scheduled start gets closer. And the predicted start time kind of tracks that. And as horses go into the barrier, they might converge. And if there are no more horses going into the barrier and still a couple, that are out the back, for example, that blue line will tend to diverge away from the scheduled race start time.
Yeah.
Does that make sense?
Yeah. Yeah. Just quick question. What feeds them? Like, is it possible to share what feeds the model? Like, this idea of you're predicting to start, and then the actual start, is it because the gates are closed? Is that what it's looking for, or is it, are there other kind of elements or characteristics in the picture that bring that up?
To predict the race start time?
Yeah.
Yeah, so the features that I've trained the predict model on are quite simple at this point in time. It's how many horses are in the race.
Yep.
How many horses are in the barrier.
Mm-hmm.
So it kind of made sense to me that, as that, logically, that if there are no horses in the barrier and the scheduled race start time is about now, that the race isn't going to start for a while. So it's kind of the foundation. The scheduled race start time is also fed into the model because that's important. The answer is the real race start time. So what was the real race start time for the training data? So it's those components. So it's the 3 questions and the 1 answer. So it was a supervised training effectively. Quite simple,
right.
Really.
Yeah,
because with some normalized data.
Sure. I was going to say, so I'm pretty sure we could probably shrink the model down, right, and have it run on something lighter. Yeah.
Yeah. So that predict model is really quite small already. The object model is a PyTorch YOLO v5 model, which is about 40 megabytes or so. So I'm in the process of, the opportunity to deploy this to the edge is a deployment architecture we want to pursue. So I'm migrating the logic to TensorFlow, and the intent to try and to get it down into tinyML type, size,
Sure.
and then hopefully we won't lose too much of the accuracy. Yep. And sensitivity.
Great.
All right. So I'll just bring that. So as we're going through the the pre-race start, we're also, there's a number of objects that we're detecting in this model. So we're detecting horses. I was getting false positives. I'll just stop there and go back a sec. Getting some false positives. The models were seeing this and detecting this as racing. So I offset that inference and false positive by also training the model on the horse animals that you see there. So we see the 2 Grafana dashboards. In the background here, we've effectively got the video image, which is getting sampled. So we're down sampling that image to 1 every second. So effectively we do, instead of doing inference 25 frames every second, 25 times every second, we're just doing it once every second. This is the background, inference that is occurring. You can just see it's in a Python dictionary. So as you can see here, we can now detect 2 horses that have gone into the barrier. So this ticker is starting to go up. And as you can see, as kind of, it's almost like the inverse. As the horses go into the barrier, the prediction starts to get closer to the scheduled race start time. So yeah, we're scheduled to start in 32 seconds. We're still predicting the start to be in 59 seconds, which is effectively a 27-second delay. And detecting the barrier empties there as well. I'll just fast forward. Now these on-screen elements has been a bit of a challenge with the on-screen elements, in terms of the training quality, the video quality for training, and the size has been, it gets reduced in this this format that we've been using.
So just a quick question there, Scott. I see you've obviously got the race predict, so that's obviously a local server there. So is the stream coming in directly into a server, and you're picking it in? I guess a bit of insight into how it all. Yep.
Yep.
So the next slide.
Yeah, no, you're right. So this is effectively a proof of concept. So we've got about 4,500 videos on Google Cloud.
Okay.
They're just video files.
Yep.
So we have tested it on streaming, but you know, getting this vision on races with this front-on view they're probably, you know, 20 to 30% of the races.
Mm-hmm.
So in terms of the training, it's all static file-based vision.
Mm-hmm.
But yeah, absolutely we move this to production. We need to stream it real time. Yep, and we can talk to that a little bit more in the deployment architecture in the next couple of slides.
Sure, great.
Just about to go, I think. So that's the first frame where we're detecting the racing has started. So that's where we can automate the no more bets scenario as well. So this is the use case where it's very latency sensitive. So being able to do the object inference or the vision inference at the edge and turn video into just, you know, a small chunk of data and feed that into the prediction engine will be, you know, of value. Yep, so that's that one there. I've got a few more videos I can show as well, but maybe I'll just maybe stop for any more questions around that.
Please feel free to send through questions. I'm watching the Q&A. Here we go. Yep, we've got 2 questions. Yep. I accidentally hit answer live, but go ahead. Going to ask the questions that you'd like.
We're just waiting for the questions, yeah?
Yeah, just waiting. I would have 2 questions. I think maybe we'd like to do it live. And again, but here we go. We saw the video angled and zoom factor changing during the demo. Is it because we get it from installed cameras? At this point in time, yes, right? Is that right, Scott?
Yeah, that's right. So they're the broadcasters have, you know, high expensive cameras that have got the ability to zoom in quite closely in and out. Mm-hmm. The production implementation. So again, this is we're a proof of concept phase. The intent of getting, you know, moving to production, we'll look at the different deployment architectures, and that will, you know, drive a different vision model training, you know, based on the camera. So for example, we could put a tiny camera at the top of the barrier and train a vision model to look at the horse rumps in the back of the barrier, for example, and then we can do the inference, you know, in that camera and send it to, you know, upstream to the inference to the race predict model. So we're not going to be zooming in and out in that scenario. It will be a fixed camera. Yeah, so that's the intent.
Yeah, sure. And another quick one from Gunter is, can you explain currently the hardware? I know this is still what's called pilot, right? So hasn't gone into production yet, but the view on production hardware.
Yeah, so it maybe if I talk to the technology a little bit, I'll just jump to.
Yeah, no worries. Yep.
So I've got a technology overview, so I can answer that question in the next slide. It's probably a bit easier with some more context there.
Yep, no, makes sense.
Any other questions before we move on?
No. Mike, do you see future need to integrate more cameras watching the scenes, like dogs approaching the race? What would complicate or simplify the analysis? along the lines of like GoldenEye or Enemy of the State, where the AI knows everything? Okay, interesting question there, Mike.
Yeah, I think for this specific use case,
Yeah.
I don't think there is a need for more cameras, because we're really focused on the barrier. So it's really having a clear view of the barrier and a total view of the barrier to be able to compare the number of horses in the barrier compared to how many are in the race.
Yep.
But you know, there's a lot of use cases, I think, in the sports scenario where you know, you could have you know, cameras on, you know, umpires' heads, for example, that are you know, racing around. Not racing. Racing's on the tip of the tongue. That are running around, you know, the field of play, for example, or maybe drones. Drones, for example, would also be offer a different perspective and provide some insight. So we have drones also in Australia that the broadcasters use on top of the barriers as well, and that's a really you know, that's a great view for, you know, using this technology to predict the race start, because we can use that drone footage to you know, to count the horses in the barrier. But it's but not many races are using that technology at this point in time.
I was going to say, I wonder how that would impact the race, right? I know it's just drones, but if it would, I don't know if it would have an impact on the horses, if it would distract them or whatever. Obviously, they're much higher up, and then there's other legal implications, which then leads to the other question which has been put in. How about the legality of such a solution during a live event that could lead to cheating on bets or whatever? Do you see anything around that? I mean, obviously, you've worked with Tabcorp, who might have some insights on this, but yeah.
Yeah, so security is important. We need to, we haven't gone into that in a lot of detail at this point, but I can think of a scenario. If the race predict isn't of ultimate criticality at this point in time. So if someone was to hack and change the, you know, the race prediction, for example, that could interrupt, you know, your high value punter that's using that information for a last minute bet, and they could gain value from that, for example. So I think that's you know, it's one scenario. Also, if you were to look at the race start automation and the stop cell, so if you are able to you know, change the stop cell to occur, you know, maybe a couple of seconds later, you can gain advantage from that. So if you were to hack the vision or hack the model in some way, that then gives you or makes it hard for the model to see that the racing has started, then you could put a bet on later and get a you know, a legal bet on. Well, maybe not so legal if you've hacked the footage, but you could get a bet on later and give you an advantage. Yeah.
Yep, that's all right. And then I saw Mike also asked about other sports tracking things, and I know you mentioned soccer game. If you want, as a bit of a fun article, I won't cover it here, but there's an interesting article on a team that tried to have an AI track the ball, and unfortunately there was a bald referee, and they found in real time there's nothing wrong with being bald, but in a soccer match you could see how the AI could possibly confuse that. So have a bit of a fun read on that one. But yeah, no, I think we've covered all the Q&A questions for now. So let's move ahead to your architecture. Yep.
Yeah, so just a technology overview. So we've got 4,500 videos, which we have captured through screen scraping of racing and punter gambling websites. So there's a whole range of metadata which is stored in a database. We've then labeled the screenshots and the vision. There's about, to create this model that we're training, there's about 600 images that we've labeled. So we've gone through the process to create that vision model. And you know, as I've described before, the output of that vision model is there's 4 labels that we're looking for. There's the barrier empty, the horse in barrier, and racing, and I've already said barrier empty, and horse is the other one. Yeah. So that work is working pretty well. And we feed that data or that metadata into a prediction model. So that's built on Keras and TensorFlow. There's about 2,500 rows that I use to train that model. I created that training data in an automated way using the vision model that that I just spoke about, and it's very important that as we're working through this and optimizing those two models, that we can have some measures for success. So I've defined some metrics, the vision success factor. So how well is our model working, our vision model working, and a PAM or a predict accuracy measure. So how well does our predict model predict the race start? So we've got a database in the back end that is collecting all of those metrics across those 4,500 races that we've got on GCP. So the deployment architecture that is an option, and I'll talk about a couple of other options on the next slide. Actually, maybe I'll just jump to the next slide so we can run there, so we can have a look at that.
So most of this is using like the open source technology and the cloud GCP. Yep. Yeah,
that's correct. Yep. So option one, so looking at the live racing and getting the steward's vision. So the stewards all need to ensure that every horse has had a fair start. So they look at that front-on vision very closely. So we need to be able to get access to that streamed vision. Then we down sample that vision or that video and take an image every 25 frames effectively, so 1 a second, and then we can stream that video into the cloud where we do the inference for the vision and predict models, and then we expose the race predict start via API to our customers, so they'll drive the automation in the back end within their data center and query the API. So that's that first architecture. That's probably the simplest one to deploy. But if we've got latency sensitive use cases such as the stop cell, so ensuring that we can stop bets from occurring, we may need to deploy cameras out to the edge and do the inference on the track. So the options that we'll look at there are cameras on the barrier, and they will, with options to do the vision model inference. So deploy the vision model out to that camera, and we take the metadata in a very low latent way, and pass that to the cloud. And we do the predict model inference, and then expose that to the automation at the back end and in the data center as well. So these again, deployment options, and we need to talk about customer in a bit more detail as to which options they prefer, and the level of accuracy they need, and there's cost is going to be a factor here as well.
Yeah, I think that's a key thing, right? And again, you mentioned having the edge. I guess the benefits are latency, but again, once you get things out at the edge, it's installing them, it's maintaining them, it's ensuring they've got the latest models up to date and everything. So there's different challenges, right? With different models.
And option 3 is really just it's kind of option 1, but instead of having the steward's vision, having the more general vision, which we don't think would work particularly well. So we don't like this really as a deployment option. We don't think it'll be particularly give us great results, because if we look at the 4,500 races that we've got using this method now, there's about 20 to 30% that we could get accurate race prediction results with. So I don't think it'll meet the need really.
Yeah, sure.
Other options that we can look at as well.
Yeah. Just quickly, I unfortunately missed one because it came through the chat. The camera seemed to be moving in the example. How are you dealing with that in the models? Like, I guess that could also add another element of complexity in there as well.
Yeah, so it's really the way that you manage that complexity is just when you're training the models, you need to look at feeding it the data, which has got the larger barrier views where the camera has zoomed in, for example, or where it's also zoomed out. So we have trained, or I have trained the model on those different scenarios. So if the camera moves a little bit, it doesn't really matter. The image gets a little bit smaller or a little bit bigger. I've trained the model on the big and small perspectives that the camera sees. Bigger is better generally because you see more data and it's easier for the model to decipher effectively.
Great, thank you.
And just working on the next steps. So again, we're just at a proof of concept stage at this point in time. So have a good discussion around the business value, return on investment, the level of accuracy our customer needs, and the various options for deployment. And then we want to do a proof of concept deployment on one or more of those deployment architectures. That's the plan. So if we were looking at option one, for example, that's probably the simplest without deploying devices out to the edge. But if we don't get if it's too latent, for example, then we'll look to put a camera out at the edge, either in the track, on the track, in the truck that they've got, like a video production truck on the track, or deploying it out to the barrier, for example, would be, I guess, the right at the heart of where the action is. And that's pretty much it. I can show you another video if you want to see it, but other than that, open for Q&A.
Yeah, there's another one from Gunter. As for option 2, which has bandwidth benefit to the cloud as only metadata needs to be pushed, would it be possible to share what you had in mind as edge platform to run the vision model inference?
So we haven't done a lot of work on this. Are we talking about the hardware devices, or?
Yeah, I think so. Yeah, I think that's where Gunter's going.
Yep.
And from my understanding, Scott, you've had a look at the Corel devices so far, is that right?
Yeah, so we've been talking to Google. So Trent has sort of organised the catch-ups with Marco, who's based in Japan, and he's a sort of an edge device SME. So he's got there's a Corel device that we are looking at potentially deploying out onto the track, which has got the ability to do inference on 400 frames a second, I believe. So that certainly at a very low latency. So that is relatively inexpensive. We don't have to deploy that to every track. We just have to deploy it to each truck, and the truck will go to multiple tracks, for example. So that's probably the one example of the edge device. And we just started talking about potential cameras that have got the ability to do inference in the camera as well. But I think right now they're a little bit more expensive. I don't have models and specs on those as yet.
Fair enough. I was going to say, I think with our team, we're all playing with different things, and here's a tiny one, like a little ESP32 camera. Again, the advantages of these small ones is the power consumption, right? Ultra low power and running things on there. But that's obviously another area where we'll explore at a different time. Subi from Dell, what are the technology and data platforms options to gather all the camera data and get data into the data center cloud? So that's an interesting one. Yeah. How are you looking at aggregating all those streams?
Yeah. So there could be a lot of races that are occurring, around the same time. So,
simultaneously,
yeah. So streaming the vision into GCP is so Google have been supporting us through this exercise, through this POC process, and effectively it's going to be a container-based technology, which is predominantly decoupled, serverless. There'll be a database which is providing the metrics at the back end, so cloud pub sub, and as you can tell, we haven't set up this deployment architecture yet, or we haven't gone into it in too much detail yet. But that's the intent. It's effectively, if we set up the image sampler out at the track, we're effectively going to have the small components or small data frames coming back into the cloud. So there's not too much in terms of video capacity and video streaming that we would need to do in that scenario. But effectively the inference is completely decoupled. All the metadata gets passed to the race predict API, and it can do the inference based on that. It's got all of the information that it needs. It's got the video streaming in the back end, or the images coming through, depending on which deployment architecture, or whether you've just got the metadata, one of those two, I guess. But yeah, we still need to work through that. We haven't.
Yeah, sure. But again, if tinyML was being in this instance to be used, then you could have the model, the inference at the edge, and then actually most of the processing is done there. So the only thing you're really doing is only saving stream data to the cloud, just to keep a record of what was recorded, right? So
so we'll have there'll be a database entity in the cloud, or in the data center, most likely the cloud, which kind of holds the race state, and how scheduled race start time, how long until the scheduled race start time, and that enables that you feed the metadata from the edge inference, for example, and then you've got the customer coming in, or the API query coming in. So that kind of brings it all together. I've got I was going to say another architecture to show you that more in a bit more detail if you like, but it's kind of like a data center deployment at this point in time. Not in the cloud. So it's like Redis, which does the decoupling instead of cloud pub sub.
Yep.
I
guess the guys from Dell would probably be interested, because they'll probably want to have a chat to you as well. But that's good. I mean, I know also with us we have like a different solutions, data intelligence, to help bring in streams and things like that. But again, there's I know good GCP obviously for storing this large amount of data. I guess there's different things like BigQuery, PubSub, some kind of Kafka, or other kind of. There's a lot of PubSub solutions now coming out, so it's I guess plenty of options for you to choose.
It's all serverless, so it should all be serverless, and just a database controlling the race state effectively.
Yep. Cool. All right. Yep. All good.
Want to see any more vision? Another race, perhaps?
There we go. Our friends from Dell are offering a Dell streaming platform option. Okay, because they've got a thing to help with the streaming piece. So
I think Trent Michael, who's also helping us from GCP, has got quite a bit of expertise there. So we're going to have a chat to him about that.
Yep. Great. Yeah, I mean, you wouldn't think, right? I mean, this is actually quite an important. I guess lots of money on being put on bets, especially here in Australia. So every second counts, right? Especially when you're talking about betting large amounts of money, and identifying when things will start, when they'll end, and so how we can kind of bring technology to get this is quite big. And then I guess also keeping that information, right? So then what data visualization, or what other kind of models you can run afterwards?
I think if we look at the opportunity, working through this process, the ability to use AI to detect objects in any scene, really, as long as you can see it, you can train a model to see it,
Yep.
and then extract that data and feed it into another AI that to make a decision. So I think there are applications not just in sports, but also in manufacturing and OH&S, looking for if you train a model to look for unsafe situations on building sites or in factories, for example, doing the inference to the edge and then potentially sounding alarms. There's so many different use cases for that, I would suspect.
Yeah, no, you're totally right. I mean, with us, we've seen examples. We've had guys write demos or concepts where, as a building site has to have the helmet on in order to be, allowed to walk through. Now, obviously, with COVID, identifying that they're wearing a face mask. We've actually got a real life solution with OH&S where we're just using, I guess, inbuilt CCTV cameras to process the image to identify if there's water being spilt as an OH&S issue, as you mentioned.
Okay.
So there's definitely lots of different. You're right. This area here, and I know the next talk with computer vision from Dell. I know they've got heaps of examples of these different areas. So yeah, there's definitely a lot that can be done with this technology. So definitely appreciate your view on this from the race side of things, which I definitely make it more effective, more precise than what it was before.
Yeah, I was thinking, if you could get vision from different sporting events, and I think about NFL, which is quite strategic, and you could use object detection to look at, the players before the play gets executed, and train a model to look for those patterns, and then opposition coaches, there's a lot of strategy which goes into being defensive or offensive. You could use AI to look at those patterns and what works and what doesn't work to maybe automate some of that, and maybe look for some nuances that the people don't see.
Yep. Oh, agreed.
Soccer is another one as well. It's quite strategic as well, in terms of offense and defensive plays.
So just another question that just popped up. Is the current step running detection and tracking or just detection?
Is the current step?
Yeah, so in other words, I'm assuming what Gunther's asking is if, once you identify an object, then you track that particular object through the life of the race, if you know what I mean.
Okay. Yeah, so we don't track the object.
Yep.
We detect it in each frame.
Yep.
And yeah, just quite simply count them. We don't track them, although you'll see it's just frame by frame, right? So the AI kind of does it, but for this use case, we don't need to track the objects.
Yep.
Potentially, we'll look for delay events. So maybe a horse jumps out the front of the barrier, which could which could mean a longer delay for the race start. So we would want to incorporate that into the prediction. So in that scenario, you'd look to capture the event. So all the horses are in the barrier, for example. We've now seen one jump out the front of the barrier. So what does that mean? Well, it could be a delay, an additional minute to the race start delay. You could also look at maybe some sensors on the front of the barrier to detect that barrier open without the race having started, for example.
Yep.
And that could you could potentially bring that into the prediction algorithm, if you like.
Yep. Yeah, and I know we had a chat obviously about different sensors as well, possibly sound, maybe identifying when something's a certain sound, or different kind of sensors, let it be even temperature or something. Again, these are all different things that could play a part in the way a race runs. But very good. Cool. Yep.
All right. Anything else? Otherwise, we close it up.
No. Yeah, no, all
Well,
good.
I'm happy just to talk to this one a little bit more as well.
That's all right. I'll continue. Just and please, if you have any questions, keep typing in. As you can see, we're tracking them a lot. So yeah, if you have anything, let us know. A big thanks again to our sponsors. And there's a bit of information on all of our sponsors. So, for example, our sponsors ARM, the Software and Hardware Foundation for tinyML, is a link, and if you're interested, have a look at the different options available to you there to support tinyML development on ARM. Maybe something we can consider for this project. And again, DeepLight, they automatically generate the models, making it a lot easier for you to create and deploy these mobile models. So actually, I'm going to jump on and as well have a bit of a test of this particular solution. So DeepLight, so have a look at their product. The other one, Edge Impulse. Again, a whole list of libraries and pieces that to help you get started on here. So again, another a site that I'm going to visit to have a look at how we can set up our first kind of Edge example. So thank you, EdgeLight. And oops, let me go back. Maxim, integrated enable Edge intelligence. So obviously sensor and signal conditioning, they've got everything. So definitely some cool boards, which we can have a look at. And again, another site that I will have a look, looking at, you know, the different varieties, biggest being 3 meg, smallest being 256. So true tinyML kind of capability to create wearables. In fact, I've created a bit of a wearable here today as well to little watch, but again, it's I won't talk about why I'm using that for because I'll probably get in trouble. And Quexo AutoML for embedded AI, so automated machine learning for tinyML solutions using edge-based sensors. So again, all of our sponsors, have a look. You know, they've definitely got some solutions out that help expedite your edge-based processing. And again, I'm going to have a look at some of these as well to have a look at how we can deploy with our solutions as well moving forward. And Reality AI, tools for building products. So again, automated feature model generation, bill of materials optimization, all the things. So again, another great vendor to have a look at some of their solutions offerings. And finally, SynSense, ultra low power sensing inference. So again, something which we can use with this model even to identify capabilities in the edge and on the field. And again, you know, we're looking, anyone who's interested in sponsoring, please let us know. I'm obviously working with my organization to be a sponsor, and we'll definitely push that forward. And once again, if you're interested, there's another talk with Mohammed Zabia on oral tongue lesion detection using tinyML on embedded devices. It should be an interesting talk. I'm going to try and attend that. Although it should be early notice. And thank you. But thanks again, Scott, and thanks everyone for asking your questions. Appreciate your things. And yeah, hopefully we'll have another presentation next month. And look forward to seeing you all. All right. Thanks, Scott. Thanks again. Thanks everyone. Chat to you soon.